Hi, my name is Kwa from ServerMonkey, and what you just saw is the Dell PowerEdge XE9680, one of the most physically imposing servers out there, and every inch is intentional. This is a 6U 8GPU platform that Dell purpose-built for accelerated compute. We're talking AI training, large-scale inference, and HPC. Everything here, from the power delivery to the cooling to the fabric, is designed around keeping those GPUs running at full utilization. It's a different kind of design compared to what you normally see in the typical rack server. This build is running 8 NVIDIA H100 XM5 GPUs, each with 80 GB of HBM3 memory. And what's more interesting is how they work together in this chassis. These aren't 8 separate GPUs talking over PCIe. They're linked through NVLink and NVSwitch, which gives you full mesh all-to-all communication between every GPU in the tray at 900 gigs per second. So in practice, they behave more like a single unified pool of compute and memory, and that becomes critical when you're distributing model layers or tensor slices across GPUs. On the system side, this build has 2 TB of DDR5 across all 32 DIMM slots, and it can go up to 4 TB total. We had one of our techs installing the memory here, and this part is actually more important than it might look. If the host memory can't feed data to the GPU fast enough, your utilization drops, and that's where you start losing performance. On the networking side, this build is equipped with a Connect X7 dual port adapter running at 200 gigs. And that's important because at this level, you're almost never running just one. You're clustering multiple systems together, running distributed training jobs, syncing gradients, moving activation data between nodes, sometimes hundreds of gigabytes per iteration. So the inter-node fabric becomes just as important as what's happening inside the box. If your network can't keep up with the compute throughput, the GPUs end up sitting idle waiting on each other. That's exactly what high-speed fabrics like the InfiniBand are designed to solve. Low latency, RDMA support, and the ability to move data directly between GPU memory across nodes without bouncing through the CPU. That's what lets a cluster actually scale and behave more like one larger system. This system uses 6 hot swap redundant 2800 watt titanium rated PSUs in a 3+3 configuration. One thing worth calling out, the PSUs use a C22 inlet, which means your standard C19 power cords won't physically fit. You need C21 to C20 jumper cables to connect back to your rack's PDU. It's a small detail, but it's the kind of thing that can hold up deployment if you're not careful. Because with this kind of hardware density, you're dealing with a lot of sustained heat. And with the XE9680, it has 6 high-performance cooling fans on the mid-tray and 10 high-performance cooling fans on the rear of the system. It's powered by dual Intel Xeon Platinum 8462Y Plus processors, or dual 4th or 5th generation Intel Xeon Scalable processors. Their job is orchestration, keeping everything feeding into the GPU subsystem properly. Everything is managed through iDRAC 9, as you've seen throughout this video. You can monitor system health, thermals, and power usage remotely. And once you're managing hardware this scale, out-of-band management is really important. Overall, it's just a really interesting system to see up close. Definitely not something you come across every day, but it gives you a pretty good idea of where a lot of this kind of infrastructure is heading. If you're scoping this for your environment, whether it's distributed training, inference, or HPC, reach out to us. We're happy to talk through what the right config looks like for your specific workload. Links in the description. I'm Kwa, thanks for watching, and we'll see you in the next one.